Hello and welcome to this video. My name is Martin Mwanda, one of the Kenya Leaf GMAT trainers. And this video is part of a series through which we are sharing some of the techniques that we share with our students during our GMAT training programs. This video focuses on the topic Algebra, which is one of the most tested GMAT quant topics. And its primary objective is to illustrate how the GMAT exam seeks to manipulate students or to use to focus on their weaknesses, one of which being the lack of concentration to subtle details, which end up being the pitfalls for students who would have actually handled certain problems without having any challenges. For instance, if a student failed to pay details to a certain a specification or condition that is set in the question stem, they may end up failing a particular question, whereas they then focus on a complex mathematical concept. And we are going to illustrate that through 3 questions from different classes of difficulty. And then the objective is going to be realized by showing how questions that are ideally not from very complex topics can be manipulated to end up being difficult questions, just because the larger or a huge majority of students are not going to get that question right. So to begin with, the first one, the question stem states that they ask whether the variable n is negative. And as usual for data sufficiency questions, you'd expect that you're going to have 5 answer choices. The first one seeking to show that the first statement is sufficient. The second one that the second statement is sufficient. The third one that both statements together is in combination are sufficient, and when they're in separation, none of them can be sufficient. The fourth answer choice is you choose this one when you find that all the 2 statements are sufficient in isolation. Yeah. Then the final one is when neither of the statements can be sufficient, be it in isolation or when they are put together. Right. And as usual for data sufficiency questions, we usually employ a student to follow a step-by-step method, wherein the first step is always to ask yourself, what type of question is it that you're being asked? And in this case, to answer the first step, the question in the first step, you'd notice that the response to this question in the question stem would be either yes or no. And then that means that the answer to the first step, the question in the first step is this question is a yes or no question. Then once you've identified that these are yes or no question, you need to identify sufficiency. What would make a particular statement sufficient? And looking at the statements that we have here, we would term them to be sufficient if they indicated to us that n is consistently negative or consistently positive, which then in this case, you would answer to the question stem as yes, and in this case, you would answer to the question stem as no. There must be consistency in our response. If there isn't consistency, then that statement becomes insufficient, right? So after we've defined our sufficiency, being that a sufficient statement is one that responds to the question stem as consistently yes or consistently no, we can then move on to evaluate statements, and we begin by the first statement. We don't jump to combine the statement, we go statement by statement. So looking at the first statement, it tells us that n squared plus n minus 6 is equals to 0. So this statement or this question ideally would be one that you just need to look at the statements and following from or borrowing from your understanding of algebra, you can actually tell whether it would yield a positive or a negative or combination of positive and negative values for the variable n. And from the concepts of algebra, particularly in quadratic equations, you can tell that when you have the coefficient or the value in this point that is representing C, so the conventional form of quadratic equations would be ax squared plus bx plus c. So if you have to find the value in this point being negative, that means then that if you're to get the values of x, one of them must be negative, so that then you're going to have this value being negative, because you usually expect to get this value c from the multiplication of the two values that are making up n. Okay, so in this case, just to confirm that, you would have n squared, possible values that would result to -6 here, which when multiplied would give us -6, would be n squared plus 3 n minus 2 n minus 6 to be equal to 0. These are the two values which when multiplied would give us -6, and at the same time when added they would give us +1, which is the coefficient of n here, which represents b, right? So then we can tell that from this you're going to have, if now we try to put or to factor out, we can have n into n plus 3 minus n minus 2 into n. So for us to have negative at this point, we'd have to have +3. So then we have n minus 2, n plus 3 to be equal to 0. The multiplication of these two terms to give us 0, which then means that if we have a negative b and a positive here, then we would expect that the values of n are not going to be either consistently positive or consistently negative. Yeah, which then means that we are not answering our question stem with any consistency. In fact, we are answering to the question stem as sometimes yes and others no. And for that reason, then the first statement becomes insufficient. And in the answer choices that we had here, if we are applying the decision tree, you'd cancel out choice A. Yeah, and also as such, since choice A, we can't use say that statement 1 is sufficient, then we also cancel out choice D. We are left with with 3 answer choices, B, C, and E. And at that point now, we consider the second statement, which states that n squared plus 6n plus n is equals to 0. Again, from our understanding of quadratics, we can tell that when we have a positive here, a positive as the sign in front of the value representing C, then we would expect that the values of n, the unknown, would either be both positive or the negative. That's the only case where we would end up with positive n here. And if we have a positive value here, then it tells us that the value of n is going to be both negative, because we can just confirm that by saying n squared, the two values which when multiplied will give us 9 and when added will give us 6 would be 3 and 3, 3n plus 3n plus 9 to be equal to 0. And of course, if you're to solve this, you would have n plus 3 into n plus 3 to be equal to 0, right? So then, with this, we can tell that n is going to be -3 and -3. It's a perfect square. Yeah, so we can tell that both of them are negative. And in case we have this point here having a negative sign, then we would expect that both of the values of n would be positive. And of course, as you can see from this, we can answer to the question stem as consistently yes, because both of the values of n are negative, right? So since we can answer to the question stem as consistently yes, and that follows from the fact that both values of n are negative, then that means that choice B here is the correct answer. Yeah, and we can stop now at that point. We don't need to go and combine the statements because we already have a correct answer choice, right? So what the key takeaway from this question is if you had a proper and a sound understanding of quadratics, then you actually then don't need to do the computations here. You just need to look at the statements and see, for instance, the first statement, you have a negative here. You would expect that the only situations that this situation would arise is when you have both one of them being negative, because this comes out of a product. Yeah, it's a product of the two values of the unknown n. So then there's no way a product would yield negative without one of them having a negative value, a negative sign, I mean. So then just with that, you can tell that there isn't consistency. One of them must be positive, another one must be negative. And with just that, you can eliminate answer choice one. I mean, you can identify that the first statement is insufficient. Then looking at the second one, by looking at this positive sign here, you can tell that you're going to get, since these are results of a product, you can tell that the only case when you're going to get a positive value here is when both are positive or both are negative, which then would answer to the question stem with consistency. And remember that you're not actually looking to get the specific response to the question stem. We just want to confirm that there is consistency. That's to say that it doesn't matter to us whether we would get the value of n to be positive or we get it to be negative. It doesn't matter if you are to respond to the question stem as no or yes. Of essence is that there is consistency in that particular response, right? So if you just have positive here, you can tell that there is consistency because both of them are going to be positive or both of them are going to be negative, okay?
You're watching Success with Bob Mwiti Show, presented to you by Appstech America. Appstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.appstechamerica.com. Appstech America, we wake you up to the unlimited potential within you.
To the second question, this one, you're given a product of values which are represented by symbols. Then the question stem states in the multiplication problem above, each of the symbols, each of the three symbols represents a positive digit. Then if this symbol is greater than the triangle, what is the value of that symbol, which should, in this case, represent a rhombus? So for us, to answer this question, as usual, we need to follow a step-by-step process. We begin by identifying what type of question this is, and in this case, it's a value. It's a value problem, in that we asked for the value of this symbol. Then that means for a statement to be sufficient, it must lead us to identifying a specific value of that symbol. Yeah, we must get a specific value of this symbol for us to term a particular statement as sufficient. And if it was to yield multiple values of this symbol, then it becomes insufficient. So with that, we can move on to look at the question stems to fetch further information from the question stem before looking at what we have in the statement. And this would help us to ensure that when you're looking at the statement, there isn't any piece of information that we're leaving out. Note that these are common error that most students would do, in that they would fail to look at the question stem and analyze what it has before moving on to analyze the statement. And more often than not, that approach would end up with the student failing that particular question because they would fail to consider key aspects that are, or key concepts that are identified in the question stem. And in this case, of importance to us here is this condition here, the condition that one symbol is greater than the other one. Yeah, this is the key consideration for this question, and it's the pitfall for most students. So when we're evaluating the statement, we have to get the value of this symbol, and we're looking at the question stem here. What we have this multiplication here and the condition. So we must, when we're evaluating the statements, we must be able to satisfy this condition. So looking at the first statement, it states that the triangle is equal to 1, right? So if we are to put 1 here, we would have that multiplied by 1 to give us the dot. And in this case, then it would mean that the trapezium is actually equal to the dot, because when you multiply any value with 1, you would actually get that particular value, right? So if we look at what we have in the first statement, we just have the value of 1. And remember that the question stem also specifies that the rhombus is actually greater than the triangle. So then, since the triangle is equal to 1, we would expect that the rhombus is going to take any value that is greater than 1. That would be 2, 3, 4, all the way to infinity, all these values. And remember that since we said a sufficient statement is one that leads us to identify a specific value of that symbol, then since statement 1 leads us to these very many numbers, then it becomes insufficient. And for that reason, answer choice A cannot be our correct answer. And that applies to for choice D, right? So then with that, we can move on to the second statement, which states that this dot is equal to 9, right? So when we have the dot being equal to 9, then what does this mean? This means that in our question stem, what we have here, the product of the rhombus and the triangle is going to yield 9, right? So this is what that means, that these two symbols, when multiplied, would give us the value 9, right? So with this multiplication here, we can try to evaluate which values, when multiplied, would give us 9. And there are only two combinations. One would be 1 multiplied by 9, and the other one would be 3 multiplied by 3, which would give us 9. These are the two combinations of values or digits that would give us a product of 9. And remember that we have to look at what we have in the question stem. The question stem specifies a given condition that this symbol must be actually greater than the other one. So the only case where we have one symbol being greater than the other one is this case only, which then means that we have just one combination. And when we have just one combination, then it means that and this particular combination does satisfy what we have here, then it means that we can actually identify a specific value of the symbol that we're looking for. In this case, it would be 9, because it would only, this is the only case where we would have 9, which represents the rhombus, being greater than 1, which represents the triangle. So then we can see that since we've identified a specific value of this symbol, then answer choice B becomes our correct answer. So the pitfall in this question will be that a student would fail to acknowledge or pay attention to this particular condition and end up terming this as multiple occasions, or a case where you'd have you'd respond to the question stem in multiple ways, in that you'd have multiple values of this symbol. So then as such, a student would term this statement 2 as insufficient. And if they went ahead and did a combination of the two statements, it would actually yield another answer. That in this case, when combining the two statements, the student would actually be able to get answer choice C being the correct answer, which is actually a wrong answer. So just like the previous question, this question 2, the focus is not the complexity of the concept that is being tested, but rather the attention to subtle details, which typically most students would actually overlook and end up doing the wrong thing, right? So on to the final question. It states that if the function f is defined for all x by the function f of x is equals to ax squared plus bx minus 43, where a and b are constants, what is the value of f3? So in this case, the key focus is on trying to identify what is the actual unknown. Yeah. So ideally, if in a normal or a conventional case, a student will just look at this question, they would see a quadratic expression where you have f of x being equal to ax squared minus bx minus 43. And if you're trying to find the value of x, then you just need to equate f of x to 0, so that you have 0 is equals to ax squared minus bx minus 43. Whereas this is actually not the best approach to this question. The best approach would be to actually try to look at the question stem, and with that, try, before moving on to assume what would be expected of you, try to imagine what would be the pitfall to this question. And if you go further in reading the question, it says that where a and b are constant, what is the value of f of 3? You're looking at the value of f of 3. It's a specific value, which then means that you actually need to get the values of the unknowns before you can move on to try and attempt that particular question. So in the type of the question, you would answer to this question as being a value question. And for you to be able to define the sufficiency, then you must be able, like I just expressed, that you must be able to identify the values of the unknown. So for us to find the values of unknown, we can try and substitute f of 3. We would have f of 3 to be equal to a into 3 squared minus b into 3 minus 43, which would be equal to 3 squared is 9, 9a minus 3b minus 43, which then would be the same. If we are now you're trying to find the values of the unknown, you would have f of 3 to be equal to 3 into a minus b, 3a minus b minus 43. So if you are to get the value of 3a minus b, you would actually be able to get the value of f of 3. So for a statement to be sufficient, it must be able to give us the value of 3a minus b. I mean 3a plus b. It must be able to give us the value of 3a plus b. Yeah. So if a certain statement does not lead us to identifying the value of 3a plus b, then it becomes insufficient. So looking at the first statement, it tells us that f of 4 is equals to 41. So if we were to substitute 4 in this expression, does it help us to find the value of 3a plus b? Ideally, we wouldn't expect that to be the case, because f of 4 would yield the same kind of expression that we had for f of 3, because there isn't anything different in what we are substituting to f of x in this case. Because if we are to substitute 4, we would end up with another form of this expression, which you're still trying to find its value. So that means then that statement 1 is not sufficient, and as such is A cannot be sufficient and D cannot be sufficient. So then we have to move on to the second statement, which in this case, it actually gives us the value of 3a plus b to be 17. And since that is exactly what you're looking for, since this is exactly what you're looking for, then we can term statement B to be sufficient. Notice that this question, following this method, didn't actually need us to do so much. However, if a student would actually go would not follow the stepwise process where you're trying to define sufficiency and end up with this definition of sufficiency where you're saying 3A plus B is the definition of sufficiency. A statement that gives us this value would be a sufficient statement. If a student didn't follow this path and went ahead and just began, solving the problem, they would end up in a situation where they have two equations, which would then lead them to even consider combining the statements, and probably they wouldn't end up with the correct answer. And in most cases, students would end up choosing choice C, which states that both statements are insufficient, whereas actually that is not true. I hope this video has been informative and really helpful for everyone who is going to watch it. Thank you.